Hi students, now we are going to look at P-type semiconductor. So already we have seen about N-type semiconductor. So whenever we add impurity atoms like the trivalent atoms, example, I said big, right? So boron, indium, gallium, like that, to a pure semiconductor, then we get what we call as a P-type semiconductor. Okay. Now we know that the germanium has 4 valence electrons, but if I add a boron impurity atom to this semiconductor, then boron has 3 valence electrons, like this. So 3 valence electrons will be bonding with the valence electron of the germanium crystal, like this. But there is one vacancy or an empty space left. So this empty space or vacancy left here without any electron is what we call as the hole. So here the hole act as the majority charge carriers in the case of boron. How? See, any one electron from this covalent bond. See, whenever some light heat energy or some light energy is applied, this covalent bond may get broken, and one electron from here jump and occupy this space, so creating a hole here. And this hole will be occupied by the neighboring electrons by the breaking of the covalent bonds, and this electron will move and occupy this space here, creating a hole. So when we look here, the holes are created in this direction, the electrons are occupying in this direction. That is, the movement of electrons will be in the clockwise direction here in this diagram, but the holes will be created in the opposite direction. So it means that it acts as a charge carrier, and here holes will be the majority charge carriers in the case of P-type semiconductor, but the electrons act as the minority charge carriers. And where the energy level of this hole will be. So when we take the energy band diagram, so this is CB, this is VB, this is forbidden energy gap. So the energy level of this hole of this boron will be nearly above the valence band. So this energy level of this hole is called the acceptor energy level. The acceptor energy level. There in N-type semiconductor we have seen donor energy level. Here we can see the acceptor energy level. So the electrons from this valence band can easily jump into this acceptor energy level, creating a hole in this region. Okay. So this is all about a P-type semiconductor, and here some mnemonics for you. So, since this boron or this trivalent atoms accepts one electron from the neighboring germanium crystal or neighboring atoms, so they are called acceptors because they accept one electron from the neighboring atoms, right? So, trivalent atoms. So I think you must understood the concepts of p-type semiconductor. Thank you.